Hello and welcome back to the second part of applications of rational functions. We're looking at the second example. So every problem has a story. So I'm going to read the problem the first time just to get an idea what the story is about. So the population density is measured in people per mile squared in a city is related to the distance x from the center of the city by the equation. So I see some rational function here. And in what areas of the city does the density exceed 400 people per mile squared? So what I got from this story is that it's a story about the population density versus distance from the city. And that got me thinking, what would be the pattern? So the further away you go from the city, then the lower the density would be. So now I'm going to reread the problem with the intention of organizing the information and getting to know what I'm given and what I'm asked to find. I see that in this equation, in this word problem, I'm given some equation. So I'll write this down because I like to familiarize myself with the variables in this equation. And when we write things down, the bond is stronger. So x squared plus 36. So I see that the independent variable is x and dependent variable is d. And I'm going to make things perfect here. I'll say dx. And I will reread the problem now with the intention of understanding and finalizing my understanding of, okay, so what is x and what is d? So what do they represent? So the population density is measured in people per mile squared. So we are talking about density or dx, which is measured in people per mile squared. I like to write the unit measurements. Oopsie. Because it actually gives me a better idea of the meaning of the variables, right? It's related to the distance x from the center of the city. So x is the distance from the city. And the equation is this rational function that we just wrote. Now I will focus a little bit more or harder on the question, in what areas of the city does the density exceed 400 people per mile squared? So when we talk about areas of the city, then we need to know what the distance would be, because that's a connection between areas and whatever independent variable I'm given here. So we need to know the intervals of x values where the population density, or when dx is bigger than 400 people per mile square. Remember, the word exceed means greater than. So I would actually now take another look at the information that I've organized, and I will put it into this statement so that I can create my equation or inequality in this case. So since I'm asked to find the distance when density is bigger than 400, I will rewrite this one more time. It means that another word for dx, or another expression for dx, is 5000x divided by x squared plus 36 bigger than 400. So when I take another look at this step in the solution, I see an inequality. And I know how to solve an inequality because the steps are well structured, and we went over inequalities in the lesson before applications. So I'll start solving the inequality. 5000x over x squared plus 36 minus 400. So take all the terms to one side of the inequality and then combine them into a single rational expression. So the denominator, common denominator, is x squared plus 36. And the numerator is 5000x now minus 400 times x squared plus 36 bigger than 0. So we'll simplify the numerator a little bit more. We have x squared plus 36 and negative 400x squared. Next we have 5000x, so we'll reorder the terms in the meantime. And then 400 times 36, which equals 14,400. So that would be a negative. So as you can see here, the leading coefficient starts with a negative. And what we want to do is take out the greatest common factor along with a negative sign from the numerator. That will make solving the inequality, the process of solving the inequality, a lot easier. So I can see that I can go here for at least negative 10 because we end with a 0. I'm going to try negative 40 as well. So 400 over negative 40. And I'm going to try 1440 over 40 actually, so that works. And 5000 over negative 40. So 40 won't work for the 5000, or would it? Oh, it does actually. So I'm going to take 40 out, and then we'll have here 10x squared plus 125 minus 125x. Remember that we are taking out a negative, so that will switch the signs of the terms inside the brackets. And 1440 over 40 is 36. And that will be over x squared plus 36 bigger than 0. Now, a smart thing to do when solving an inequality, when a negative constant is a factor, is reduce this negative constant or divide both sides by that negative constant. Now, remember that when solving inequalities, we should not simplify expressions that contain x. That's because we remove solutions and that skews the answer. But dividing by a constant is perfectly fine. And down here we have x squared plus 36. And one other change that happens when we divide by a negative is the direction of the inequality, which will now switch to less than 0. Now, we'll check and see if we can factor the numerator. The coefficients seem a little large, and by looking at it, it's not going to be a perfect square trinomial. We can go for the quadratic formula. It can be easier and faster sometimes. So 10x squared minus 125x plus 36 will have the x value equal to negative b, so 125 plus minus square root b squared, which is 125 squared minus 4 times 10 times 36. And this all will be over 2 times 10. So let's take a look at the root. So we have 125 squared minus 4 times 10 times 36. And we got 14,185. I'll check and see if it's a perfect square, so it's not, which tells me that, it's a good idea that we went for the quadratic formula. So I'm going to round the answer to the nearest decimal place. So the square root of 125 squared minus 4 times 10 times 36 is 119. And that would be over 20. So we get two values of x. So we'll say x1 equals 125 plus 119 divided by 20. which is 12.2, and x2, which is 125 times 119, minus 119, divided by 20, which is 0.3. So let's take a look at the chart. So when we talk about the distance from the center, the distance has to be bigger than or equal to 0. And I'm going to draw the distance line, number line, and we're going to list the numerator and denominator. So here goes the sign of the numerator, which is 10x squared minus 125x plus 36. Here goes the sign of denominator, which is x squared plus 36. And last but not least, we have the sign of the rational expression. Which is 10x squared minus 125x plus 36 over x squared plus 36. So we're going to start at 0 and finish to infinity. And the zeros are at 0.3. Again, we don't need to scale. We just place them in order. And these will be the zeros of the numerator. The denominator, if you try to solve, will have no zeros because x will be plus minus root of a negative number, which doesn't exist. And when this is the case, it means that x squared plus 36 is either always positive or always negative. So it doesn't actually cut the zero. So it's positive if it is above the x-axis, so it doesn't intersect the x-axis, doesn't have a zero value, right? Or below the x-axis. In our case, as you can see, it's going to be above the x-axis because it is a parabola that is shifted 36 units up. That tells us that the values will stay positive all the time. So, and since we just talked about it, let's make this all positive. And now let's take a look at 10x squared minus 125x plus 36. Now, in between the zeros, since this opens up, it's a parabola that opens up, the value will be negative. So that would be negative here. And outside the zeros, positive. So let's multiply the signs. So we have a plus, a minus, and then a plus. So we are going to say that the solution will be when the expression is negative or when the distance is between 0.3 and 12.2 miles. And obviously that kind of makes sense when you think about it. 0.3 miles means that 0.3 miles from the center of the city. So the center is a point, so it makes sense to say that the first, building or house will be 0.3 kilometers, miles from the center of the city, right? And there are offices as well in the center of the city, so not real houses, right? So this is a reasonable number. And after 12.2 miles, the population concentration will start decreasing, and it will be less than 400. So I hope that the solution, this problem made sense and you learned something from it. Always approach solving problems with confidence. Do not stress yourself out thinking that you have to solve the problem right away. Be patient with yourself, read the problem more than once. The meaning will be there, and think that, okay, I just have to picture the situation and put it into the equation and the numbers. And last but not least, interpret the solution. And sooner than you know, you will become a lot more confident in solving word problems. As always, thank you very much for choosing to learn from me and for listening to this lesson. and let me know in the comments if you have any questions. Thank you.